Hey, welcome back. Let's do some financial modeling. I thought since we had a little bit of an extended layoff over spring break, we could do a brief review of finding optimal portfolios, right? So let's get into that. We'll go back and work off of a spreadsheet under in-class exercises. We scroll down. The one I'm going to open up is March 5th, three assets, portfolio matrix operations, working version. We'd filled that one out. And so remember, we've got the inputs into our optimization problem look like this. Actually, if we go to chapter 9, it's nicely summarized. We've got a matrix of weights, right? An n by 1 matrix of weights, the percent of our money invested in each asset. And then the R matrix, same dimensionality, as each element is the average return for the investments. And then the variance covariance matrix shows how those asset returns vary and covary with one another, right? And so the expected return X transpose times R for the portfolio, and then the portfolio variance X transpose times S times X. So this video will just go over the optimization exercise that we've done before, right? And so to do that, we use Solver, right? If you don't have Solver on your Excel-enabled device, do a Google search, how do I enable Solver in Excel? And maybe your operating system too. But if on the data tab, if you click on solver, I'm going to just click reset all to get rid of all this dialogue. And so let's see, why don't we start by setting a return objective, right? Return objective. Suppose we want a portfolio with a return of at least 10%, 0.1, right? What's the best portfolio that has an average return of 10%? Well, investing 100% of our money in asset 3 would give us a return on average of 10% and a standard deviation of 13%. But the best portfolio would be one that has a return of 10% and the minimum standard deviation, right? Minimum risk. So let's do that optimization using Solver. So the objective cell is actually when we minimize risk, we want to find the portfolio with a return of 10%. So actually what we want to minimize is the portfolio standard deviation. So set P3, the portfolio standard deviation, not to a value of maximum, but to a minimum, right? And then by changing the cells, we want Excel to play with different values of the weights until it minimizes the portfolio standard deviation. Subject to two constraints. First, the first constraint that we'll put in is right? So on the dialog box, you click add to add a constraint. The first constraint we'll put in is that the weights should sum to exactly 1. So set this inequality as an equality. Set M5, the sum of the weights is what this little formula in M5 says. The sum of the weights should exactly equal 1. And then the second constraint that we want relates to the return objective. Right? Minimize risk subject to the portfolio's expected return here that's computed from all this stuff, subject to the portfolio's expected return being greater than or equal to 10%, right? The return objective, we want a portfolio with the return of at least 10%. So clicking solve will change the portfolio weights and show us the best portfolio out there, right? And these are the weights that I got. The portfolio's expected return is 10%, and the standard deviation is substantially less than it would be if we just invested 100% of our money in asset 3, which is obviously not an optimal or efficient portfolio. Right? But this one, given a return objective, it has the lowest risk. Right? So it lies right on the efficient frontier, which is where we want to be. Great. Let's do one more. Let's do a risk limit. And that'll be a nice way to wrap up the video. Suppose we have a risk tolerance. We can take a standard deviation of up to 14%. Right? Suppose the limit, the upper bound on the amount of risk we want to take on is 14% standard deviation. Okay, so what's the best portfolio for that? Well, it's the one, find a portfolio with a standard deviation less than or equal to 14% that has the highest expected return, right? That's the best portfolio. So back to Solver on the data tab. I'll reset the dialog again just to be safe. Reset all. So here, our objective is set the portfolio expected return to a maximum value, right? Maximize portfolio expected return by changing the weights again, by changing the cells, these weights, right? Subject to two constraints again. The first constraint, that the weights sum to exactly 1. M5 equals 1, that's one constraint. There it is. And then the other constraint is that relates to the risk tolerance, right? The other constraint is the portfolio standard deviation computed in this cell, right? As you change the weights, the portfolio's computed standard deviation will change. So this constraint says that the portfolio's computed standard deviation should be less than or equal to the limit that we set, right? 14%, 0.14. So now we click solve. Excel will alter the weights again. And then here's the portfolio, the optimal portfolio with the standard deviation of 14%. It's the one with the highest average return, 14.46%, right? Subject to this limit, we've maximized expected return. So that's also an efficient portfolio. Great. Well, thanks for coming with me on this review. We'll see you at the next video.